Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Optimization of Waveguide Selection for Enhanced Performance in High-Configuration Multi-Beam Combination Systems. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the unique research topic for the multi-beam combination systems. Here we have automated the systems and worked with the higher configuration systems. So before moving to this video, let's talk about that what exactly we will cover into this video. In this video, initially we will discuss about whatever the research domain we are doing, in which application areas it can be used, then whatever the code we have designed, how to execute it and what are the software requirements to execute it. And then we will discuss about what the current systems are currently doing and what are the challenges in that. Finally, in order to handle those issues, what proposed work is doing. Finally, we will give the experimental outcomes and finding overview. Let's talk about the application areas. As the developed system is related to the multi-beam combiner, so this is related to the different domains which is not commonly done by the researchers. So the application areas are telescopic interferometer, where the different telescopes are being used to see the farthest point which cannot be easily covered by a single telescope. Now the laser beam that is received from these telescopes are to be combined in order to get the overall picture on a single screen. So there this research area actually works. So we have developed specifically for this domain for the telescopic interferometry. Other than that, the technology can be used in the lidar systems, then the laser show systems, because the laser beams can be combined in order to get the different patterns and the visuals. For biomedical healthcare applications, where biomedical imaging can be one of the application area where this technology can be used. So let's see how the code is to run. So whatever the code we have designed, there is a folder named code, under which we have the 4 different folders. These 3 folders are for 3 different algorithms that we have implemented, and this is the overall comparison between all the 3 algorithms. So in order to run the code, you just need to open the folder, and then as the code has been developed into the MATLAB, you must have the MATLAB software with you. So MATLAB version that I am running is right now is 2019A, but you can run it in 2015 or above, but make sure it should be a full version. So to run the code, you just need to go to the folder where the code has been placed, and you just need to copy this path, and then you just need to go to the MATLAB, and here you just need to paste the path and press enter. When you will press enter, you can see whatever the files were there, these are available now here to run. So you just need to open this code. This is for 8x8 and this is for 9x9. Now to run the code, you just need to click on the run button and you can execute the code. This is how the code can be executed. Now let's see that what exactly the problem was and what people are doing. So this is the one of the base paper, not specifically this one. So here they have designed the discrete beam combiner by for the interferometry. There they have evaluated the system by using 3x3 and 4x4 array of the waveguides. So you can see this concept where different array of telescopes has been used to see the farthest things. The laser beam is being used in order to see the particular things. So whatever the beams we have received, those are to be put on the different array of the waveguides. So it can be 2x2, 3x3 or 4x4. So in 3x3 waveguides, there are total 9 waveguides, and we need to select best waveguides for these 3 telescopes so that we can get the pattern on the screen. So this is basically the problem. But the people those are currently working in this domain, obviously they are very less. Firstly, secondly, discrete beam combinations has been developed for the smaller array waveguides like 2 by 2, 3 by 3, or maximum of 4 by 4. The challenge is like for 2 by 2 or 3 by 3, initially it was doing by the manual procedure and by doing some mathematical calculations, but when the beams are being increasing, right, for 4 by 4 there are 16 waveguides. Till that the manual process is okay, but when it is 8 by 8, that means 64. So out of 64, which waveguides are best suitable for these three telescopes? That is the challenge one. So in order to automate the process, we have proposed the scenario that optimization algorithm can help us in achieving the targets. And the second modification that we have done in this is like, in comparison to the existing system, those were working on the small set of arrays of waveguides. We are working on the higher order, means 8 by 8, 9 by 9, and so on. So in this application we have designed the higher configuration system for the waveguide selection to automate the process in order to get the laser beam more accurately and with a more pattern on the screen, with the PSO algorithm, with gravitational search algorithm, and firefly optimization algorithm. So all these algorithms has been implemented for two of the configuration, that is for 8 by 8 and 9 by 9. So in order to run the code, as I'm going to run this, we just need to run this code, and here you can give the different wavelengths in nanometer in order to evaluate the outcomes. So the paper to which we were analyzing, they were having the wavelength from 650 to around 850 something. So we have also did the comparison here. You can see we did from 640, here it is FA for 8 by 8 waveguide set with the 640 nanometer wavelength, up to, with the difference of 1010, we have run it for, here you can see 690. So you just need to give here the value, that is for example 650. It is not restricted to 650 or 90 or something. Whatever the nanometer wavelength you want to give, you can give here. So when you will press enter, it will start processing. The iteration of the PSO is being processing, and for every iteration whatever the fitness has been achieved is shown here. So after all the simulation, the outcomes are in the terms of like visibility and the intensity of the three different of the selected waveguides for the telescope, and finally the array and the SNR values, minimum and maximum value of SNR has been given here, 1 by SNR has been given. So these values has been saved. Here you can see, as I ran the code for the 640, the value is been saved by using the command that is we have mentioned at the end. So here it is, so I'm commenting it. So it can be run for 8 by 8, and similarly it can be run for 9 by 9. So the same configuration can be plotted for the 640 nanometers, and it will calculate the fitness. So what exactly the fitness is? In our scenario, the fitness is being calculated in the terms of the intensity. Higher the intensity, better will be the solution, because we need the maximum laser beam intensity in order to get the patterns in an effective way. So we have run it for the PSO. Secondly, we do have the for the GSA, gravitational search algorithm, and thirdly for the firefly optimization algorithm. So after running all these codes for 8 by 8 and 9 by 9 configuration, we have saved the results as I already shown you for the PSO 8 by 8. Then we put the files in a single folder and did the comparison. This is a comparison for 8 by 8 configuration of PSO, FA, and GSA. So we did the comparison in terms of different parameters. Those parameters are like normalized intensity, then we have analyzed for the visibility, and finally did the comparison for three algorithms, and last one is for the SNR, minimum SNR and maximum SNR. So I'm gonna run this comparison for 8 by 8. You can see the results. So let's talk about the results, that how the results are there and what will be the outcomes. So we do have these graphs with us. This is the normalized intensity for different baselines using PSO, FA, and GSA by varying the wavelength. So you can see The outcomes with the baseline number 3 with all the three scenarios is the highest one, which is around 0.6 to 0.08, and for the lower baselines these are lesser one. For the next parameter that we have analyzed, it is the analysis of the visibility. So you can see these are the curves for the visibility for the three different algorithms, and from the simulation we have got that GSA is achieving the highest visibility in terms of 8 by 8 configuration. The next parameter is the overall visibility, means summation of visibility at different wavelengths. So GSA is having the maximum visibility. So this is the intensity curve calculation. So intensity is the highest with the FA algorithm, so which is the orange color. Here you can see the representation. So the analytical study has been conducted for it. This is the SNR minimum and maximum. So the SNR minimum SNR is with the GSA, and maximum is also with the GS 1 by SNR. So here the analysis has been conducted for three different algorithms and shown that which of the algorithm is best. So same has been done for the 9-1. So we got the results and did the comparison in terms of the same factors but the configuration of 9 by 9, and the selection criteria has been evaluated that which is giving the better results. So FA was getting the better results in many of the scenarios, even for you can see for the here, as you can see, the initial intensity, visibility, these are varying as per the parameters that we have given. So further modification still possible. So higher order waveguide selection is a very rare area of the research and not been done by recent, where the automation has been opted by using the optimization algorithm or any automated algorithm to select the waveguides. Manual procedures are still under process and are still a challenge. So it is a very unique topic of the research and further can be extended. We have implemented it for the telescopic interferometry. So other domains can also be explored from the same. So for more details you can contact us directly and can get the information. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.